Today we want to talk about gRPC. gRPC is a remote procedure call protocol from Google initially. It uses binary format for the data transfer. It uses protobufers, which makes the size of the data transfer very small, and really concentrates only on the data, because if you think of JSON, then you always have the field name and then the value in there, and you have a lot of floating stuff around it. So you always carry this schema with you in every request and response, which is nice when you look at it as a human, but it's also totally obsolete in a sense. So you would not need to do that if both client and server know the scheme or a schema. gRPC tries to do that by first defining the schema, and then you can use it as a client and as a server, and only transfer the data. And with that, it's super fast. It also uses HTTP 2 out of the box, which also helps by not opening new connections all the time, but keeping the connection open. And it has some advanced features we might get into later, that you can do streaming of stuff from the client to the service and back, and that really easily. It's natively built in there. So that's quite a nice feature. So I guess let's get started. One note, Quarkus 3 is out. So have a look at the update guide. I updated a couple of projects already and went quite smoothly. The most changes you will have when you have more Hibernate stuff, because they updated Hibernate to version 6.2, and that had some breaking changes. Yeah, as always, let's get started with a new project. What we need is Cradle. We use Kotlin DSL, Java 17. We need gRPC. We need Kotlin. And that's initially it. So you can download that project and you can have fun. I did that already to be a bit prepared. And here is our initial project. If we look here, we see the dependencies. We have Kotlin stuff, the gRPC stuff, and...
Can you increase the font size a little bit?
Even more?
A little bit. Yeah, it's better.
Okay. So, when we look at our build Gradle file, we see here the dependencies, the gRPC dependency, the Kotlin stuff, and standard Quarkus stuff. So, to start with a gRPC API, we need to first define how the API should look like. And as I said, we use protobufers for that. And what you need to do is you need to create a proto directory in the source main directory. And Quarkus will use that to generate the code files for you. And here we make our proto file. So proto files are not that complicated. Initially we have there's a couple of versions. We use the latest version 3. That's just defining which syntax you have. And then we can define a service. Let's make our products service. And a service is just a collection of functions that you can later call. And such a function is a remote procedure call, RPC. And let's make a getProduct call. And it can, has a parameter. So the product request, and it returns something, the product response. So now we can define these. In gRPC, these are called messages, these transfer objects. And we do that just by creating a message, request. And in this case, if we want to get a product, we just need an ID. So we define string product ID. There's something missing here, and that is we need to define in which position in the proto buffer this field is coming.
Okay.
Again, as I said before, the proto buffer is a binary format, and it needs to know where stuff is coming. And in this case, we say it's on the first position, and you, if you want to safely upgrade your API, for example, by adding something, if we have string product name, if you now want to have it here written before that, because for you this makes more sense, you must not change these numbers, because now the format looks different.
Okay.
Now you cannot deserialize the old API anymore. Instead, what you need to do is like this. So, and you must not use any of the numbers twice. So that's how you do that. There's a couple of types, and we can see some more for the product response. Returns, is it the right thing up here? String ID also. We have a name, also a string, one. Then there is for numbers, there's a couple of different ones. So there's int 32 and 64. These allow signed values. Then there's the unsigned ints, 64 and 32, which obviously only allow positive numbers. And then there's this sint. These also allow unsigned numbers, but they are more compact for the binary data. And that is the following reason. Proto buffers, although we say we use int 32, for example, price in cents, it does not always send 32 bytes. If I set a value of 5, I only need 1 byte to put a value of 5 in there. So what proto buffer is doing is it uses 7 bits to put in the number, and whenever you need more than 7 bits, then the first bit, I think it was 1, and that signals there comes another bit for this number, or another byte for this number, and then the next 7 bits are used. So if your number is small enough to fit into 7 bits, then you only need 1 byte. So it's really trying to save bandwidth or store space. And that's a problem with the int 32, because, like you might know, for negative numbers, normally we have the 2's complement. So a -1 is basically all filled with 1s, all the 32 bits. And then you need to send a lot of bytes. And this sint, they do it differently. Basically, they say if you have a 0, it will be represented as a 0. If you have a 1, it will be represented as a 1. If you have a -1, it will be represented as a 2. If you have a 2, it will be a 3. And the -2 will be a 4. When it transfers it. You don't see this.
No.
But the fun is, if I now have a -1, it's a very small number. And it only needs to send 1 byte. So that's just to illustrate how much goes into this binary format. and how much it can help to not use or save on bandwidth. But we will use unsigned because, I mean, prices are usually positive for products. And there's also stuff like Boolean. So that's already what we need in here. And now we can basically just do Gradle. Nice. We can just build it once because Quarkus is, when you compile, is generating code for these files, for these classes, and it will be put into the build directory. Let's see where. Okay. Yeah, I mean, we didn't implement it yet, so we have here the build directory where Gradle outputs the generated stuff. And then we have Quarkus generated sources, and we have, did it not generate it? It should generate it.
It failed.
Let's see, plugin fab. Nice.
Please specify option
Ah,
Java package.
yeah. Okay. So I forgot one thing. We need to specify in which package it should put this stuff.
Okay.
So yeah, let's define some Java package. This is an option. This is not part of the standard gRPC. Standard gRPC just defines that you can have such options. And then depending on which plugin you use, it can have different options. So let's see if that works.
Looks better.
Yeah. Okay. So now we have here the product service. We have a Mutiny product service gRPC, products, product service bean, service client.
Okay. A lot of files.
Yeah. So let's have a look. So first we have here the products, which has a product request, what we defined. It also has a ton of, so implements some generated message from protobuffer stuff.
Okay.
Has a lot of ugly stuff. It has a get product ID and probably also some set product ID or no, parsing. You need to create a builder always.
Okay.
And then this builder leads you here, and the code following doesn't really work. And here's this builder, and this builder can set like the product ID
somewhere.
So you see like
a lot of code.
What the hell?
Okay.
But it's generated. And then we here have the product service, which defines our get product method. It returns a product response, not directly, it returns a uni. This is a Quarkus way of doing reactive. You might know RX Java or stuff like that. That's the Quarkus way of doing that. And as a parameter, we get the request in there. So now we want to use this. So
that all was generated just from our proto file.
From this small proto file.
Okay.
Yeah. So we go here, we create our awesome package.
Oh, you did a typo. Quarkus.
No. No. Okay. So let's implement our Mutiny product service. I call it Mutiny now because I want to later show you also a different way of doing it. Here in this service, we need to implement this interface that we just saw, product service. And we need to tell Quarkus, hey, this is a gRPC service. And now we need to implement these members. We can remove this question mark here. This is just because it's generating this from a Java API, Java interface, so it could be optional.
Okay.
But we defined the service in gRPC that we need this, so it will be there. And now, let's first return something simple. Return uni. So this is the reactive way of doing things. It's already a bit bloaty.
Okay.
Create from item. And here we use the product response, new builder, apply. And the ID is our request product ID. And then we also had name shoe. What else? What are you complaining about? Ah, the build. One interesting note, all fields here in the protobuf, they are always optional.
Always. Okay.
In Proto 3, there's no way to say you want the required field.
Okay.
In Proto 2, there was, but they removed it. I don't like that decision, but it is what it is.
Okay.
So
that would be a correct response object.
Yeah, that would already be correct.
Yeah.
So you always on the client side, you need to check
if it's there.
If it's there or not.
Okay.
Which is not ideal, in my opinion. They argue it would be more safe in the way of upgrading APIs because you always need to check. And they had issues that somebody removed the required field in their services, and then everything broke down because they expected that the required field is there. But I would argue if you if you intentionally break the API, you can always break it.
Yeah, on iOS, when you use CloudKit in combination with core data, you have the same thing. So every field is optional there because then they can sync every time.
Yeah.
And but on the client side, it's
horrible.
You always have to check is it set or not.
Yeah. And then you need to handle it anyways somehow.
Yeah.
And but let's see. This thing runs already. Nothing to show. Okay, so the server is up and running, and we see one detail here. Quarkus tells us we are using the legacy gRPC support with a separate new HTTP server instance. So here's also already what we can do to use the new stuff. As an explanation, in the past they had a separate gRPC server. And for legacy compatibility reasons, it's still active by default. But in the meantime, there's a gRPC server in Vertex, which is the underlying framework under Quarkus. And you can directly use that one, which is more integrated, faster. It uses the same port as the REST stuff. And so that makes things easier. So now we are using the right one, and we can test this. How do we test it? For example, we can use Postman. And we can increase the font here a bit. So we want a new request, and here we see gRPC. So we can click on that. And one nice thing about gRPC is that it supports introspection. So you only provide like the server URL, and it finds out what the server offers.
Okay.
So you can already see you have the get product, and we also already have some health check. So that's directly coming with it. And we have here our get product. And it's actually a bit too big, I think. Okay. Our request, we need to save it to a collection. One difference is you cannot save it to a normal collection. It is a special collection, so you always need to have a new one. Quarkus, gRPC. No. Do I have already one? Select the collection. Okay. Great. And the request name is get product. Okay. So we have this request now. And now up here, we can compose the message. And here in Postman, we can write it like JSON for easy readability for us. And what we can do is we can generate an example message. So from the schema that Postman got from the server, where it also learned that there's a get product, it also learned that the request looks like this.
I just wanted to ask how...
And it knows it's a string, so it generates some random string. And yeah, that's already all we need. So we can invoke this, and we get back this here.
Yeah, can you...
yes, fixed.
Yeah, correct.
So it's like, we do like shoe1, like this. And that's already how you get started with Quarkus and gRPC.
Cool. That was easy.
Yeah. I hear that a lot when we do Quarkus stuff.
Yeah, when you are familiar with all the stuff, then yeah, of course. So